that what is the accuracy I need, and then if I use certain type of data, what will be the its accuracy, horizontal accuracy as well as vertical accuracy. So in this also satellite, when you talk about this, what are the possible errors in generating DTM? See, suppose I generate a DTM, that means I did not have the information for the whole area. I had information only for the part of the area in terms of contours, in terms of points, etc. And then suppose that I wanted to convert into whole spatial location, so then I have to interpolate. So when you interpolate, then errors are also occurs. It all depends upon the density of the points. So that the more dense, the more accurate you can generate better DEM and DTM. But at the same time, you are going to increase the more number of points. So then what will happen is your cost also multiplies. So that's why we have to keep a something which is rational and something which is economical. When you also classify an image, suppose this is a satellite data, you convert it into your classified output. So then what happens is that you have, these are the classified features like a forest, forest is there, agriculture and urban. Reference data also same type of information is there. Suppose you know, and then you went to the ground and you found that these are the forested areas. It should be, the forest has to be like 64 and 24 and then 22. But when you come to the classifying that, instead of 64, probably it is classifying to 62. So like that. So then there is all these things, there are differences are coming. One is the reference data where you know exactly that what is the area of forest, what is the area of agriculture, what is the area of urban. But when you classify it, you don't get exactly all those things. So maybe you may get less, etc. So if you see this diagonally, forest it has classified into 62 pixels out of 100, and then 18 pixels have been classified in agriculture correctly, and then urban is classified 12. So then if you combine all together, so is 62 and then 70, 80, they are 92. So that means 92% of pixels are classified correctly, and then remaining pixels it did not classify correctly. So that is error. So why do we study errors? We have to study errors because whatever the GIS database we generate, it is an approximation of the real world. So somebody says that this is the GIS layer pertaining to your area, but at the same time they should also realize that it is not exactly what is there on the ground. So then you should also know those things. So then that will help you to further analysis and other activity, whether it is properly classified or taken all the values what is there on the ground. And then we also say that geographical data, when you collect it, that entire process are not sufficiently reliable and error-free. So when you say, and you take a data and then process it, they are not, and then that means when you take the data, there are possible that errors you are taking, and then when you enter into that, then in the processing also, you also come across errors. Suppose I digitize a line, so then I am not digitizing exactly on the line what is there in the background. So that means I am creating an error. All these things also, that is the reason we also need to study errors. The spatial database, whatever using, has problems because the real world phenomena are not always discrete but also fuzzy in nature. So you might have also been said when you are talked about data models, raster vector data model. That time it is also said that some of the features are discrete, some of the features are continuous, and then you also said object and then continuous features. So when you say discrete feature, if you have a boundary, administrative boundary, soil boundary, etc., you have a forest boundary. So those are all the discrete type of features. When you take a height information, it continuously varies, and then that is called a what I say is continuous feature. And then some of the things like you give a distinct name for any features. So sometimes it is not possible to have a distinct name for any feature. So then it is called a fuzzy in nature. Suppose if you take a boundary, soil boundary, so maybe part of it, that particular soil is available, both the part of soil. Suppose you say red soil and black cotton soil, but it will not change in a sudden manner. It changes in a smooth, in transitional phase. So that means those areas is called is a fuzzy in nature. So then you cannot specify exactly it is this feature or other feature. So some more examples of what I say is variation of natural phenomena. When you talk about the errors and data quality, when you try to draw a line for a bank of the river, so then sometimes it is difficult because that bank of the river, it may contain the width is very wide. Maybe it can be 100 meters or 500 meters sometimes. So then where do you put that line exactly? So that means it also naturally also the line will be varying. And then as I said earlier, where is the boundary between two soil types? Is it possible to put an exact boundary that if I put a boundary, then left side of that is one soil and then right side of that line is another soil. So these things also to be taken care. So those things may not be the errors, but they are also naturally occurring. So that's why we have to be very careful. When we come to the basic concepts of data, as I mentioned earlier, data is a collection of facts which conclusions may be drawn from that. And then quality is you specify certain standards. ISO considers quality to be totality in the characteristic of a product that bear its ability to satisfy stated and implied needs. So that is given by Godwin 1999. So that means you have some product. It is to be totality in characteristics. So then you specify and then accordingly you generate a product. That means it is taken care of the quality that is needed. So error, as I mentioned earlier, error is it encompasses both the impression of data and inaccuracies. So another important thing is accuracy and precision. I think somebody also might have demonstrated on that. So then when you press a button, you get a position.